Question number 7 of the PhilNITS FE afternoon portion of the exam. In this question, we are being asked about the Fibonacci sequence, which is a sequence in which each number is equal to the sum of the two preceding numbers. In this question, the sequence starts with 0 and 1, and the first 10 values in the sequence are 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. For example, the eighth number, 13, is the sum of the two preceding numbers, 5 and 8. This is the eighth number, and the number is the sum of the two preceding numbers. So the eighth number, 13, is the sum of the two preceding numbers, 5 and 8. The function Fibo takes an integer value n as the argument and returns the value at the nth position. Here n reflects the position of the number in the sequence, starting with 1. When n is 9, the function returns 21. Okay, so if it's 8, then the number returned is 13. If it's 9, the number returned is 21. Okay, if we look at the program, we have two blanks here, A and B, and we gotta know what would be the correct answer to fill in the blanks. And to do that, we can first look at the answer group. Here we have several possibilities, and in my case, I was able to choose the correct answer, I. And to explain how I arrived with the correct answer, I think I need to also admit that this question was a bit daunting at first, because it seemed to me a question that would take a bit of my time, or more than a bit of my time actually. And the fact is, I found it difficult at first when it appeared in the list of questions, but eventually when I came back to it after answering the other questions, I was able to figure out the correct answer, which is I. Now, the first thing that I needed to know was, if we are going to do this function Fibo, and it seems like based on the choices that we got here, we have to call it over and over and again. The next thing that we need to do is to find out how we can end the continuous calling of the function Fibo. And if we are to use the choice that I also found out when I was looking at the answer group, this one, then we can see that if it's 1 or 2, then the answer would be n minus 1. Now, it's a bit difficult to just choose whichever choice, and I think that what we really need to do is look at whether, if this is the correct answer and we got the inputs, would it produce the correct outputs? I think that should be the technique there. So if it's 1, n is 1, would we get 0? Because 1 minus 1 is 0, and we can say yes. If n is equal to 2, 2 minus 1 gives us 1, would it give us 1? And so we do get 1, and that's why the answer here is n equals 1 or n is equals to 2. And again, if you chose another letter, you gotta test the idea. Test whether it would give you the correct answer if you chose another letter. Okay? Now, we are now in blank B, And the way to see if this is also correct is, of course, to test whether if we are going through the Fibonacci sequence via the incremental ends like this 1, 2, 3, 4, 5, are we going to get the correct answer? So for example, our n is 3, we are supposed to get 1, and if it's 3, then it's not going to go here, it's not going to go here, it's going to go here. And if that's the equation, then we put in the value of n, which is 3 here, and that's why it's 3 minus 1 plus Fibo 3 minus 2. If it's 3 minus 1, then that should give us 2. And we know that if it's 2 here, it'll go here. And 2 minus 1 is 1. And that's why this one gives us 1 here. And this one is 1. 2 minus 1 is the one that we can see here. Okay, if we call Fibo again and put in as argument the input parameter 3 minus 2, that should give us 1, and it will go here, and 1 minus 1 should give us 0, and so 1 plus 0 is equals to 1. Now, if we already have this list, actually, we can also just look at it because we already have computed what would be the output, right? So for this one, if it's 1, then let's see, it should be 3 minus 1, 2, which is the output of which is 1, and this is this one, and 3 minus 2 is 1, the output is 0. So that's how we get 1 plus 0 equals 1. And that is the correct answer for N3. And if it's N4, N4 is going to be like this. 4 minus 1, which give us 3. 4 minus 2 give us 2. We know that N is equals to 3. Then the answer would be 1. That's why it's here. And then if it's 2, we know that if it's 2, the sequence in the Fibonacci would give us as output 1. So 1 plus 1 equals 2. And is it correct? If 4 is the n, the Fibonacci should give us 2, and that's correct. Again, Fibonacci is supposed to gives us the sum of the two preceding numbers. 1 plus 1 equals 2. One more. N is equal to 5. The equation says here that if you look at the program again, it's not 1 or 2. It has to go to this one. And 5 minus 1, as you can see, it's here 2, gives us 4. 5 minus 2 gives us 3. And we know that if it's 4, the output, if it's 4, is 2. So that's why we have 2. If it's 3, the output is 1. That's why we have here 1. If you also have this list here, 4 gives us 2. Okay. 3 gives us 1. And therefore, the sum of the two preceding answers would be 3. And 2 plus 1 is equal to 3. Therefore, the correct answer would be this one with the n equals 1 or n is equal to 2, and the Fibonacci function n minus 1 plus Fibonacci function n minus 2. as the parameter for the second one, and that's the letter I